Hello, everyone, and welcome to our webinar. Today, we're going to be talking about mobile application development best practices. Thank you very much for being here. And if you have any questions, please don't hesitate and just write them down in the Q&A section. And then we'll be taking care of answering them as we go. As per technical questions, somebody is here as well to help you out with that if you have any trouble. So without any further ado, let's start talking about application development. Just a short notice before we get going, as I will not be talking about the implementation per se. We will be talking about the general concepts of application development, and then how can you tackle it in the right way. A bit about me. My name is Yunus Aitmo, and then I do work as a software engineer here at the College of Science and Engineering at Hamad bin Khalifa University. And I have started doing software since, I don't know, 1998 at the beginning of HTML, JavaScript, and then kept going and integrated that into my research. And now it became kind of my my main field of my main professional field, I would say. So here is the roadmap as what we're going to be talking about. For the ones who just joined, please don't hesitate. If you have any questions, just write them down in the Q&A section. I will be taking care of answering them. So the content that we'll be covering today is shown here. So we'll be talking about the evolution of application development, mobile application development, how it was, and then how it is, and then how it might become in the near future. This is very fast evolving, I would say, technology, and then we'll see how actually evolve that fast. The second point is how to plan your application development project. This is very crucial because some people, they start implementing basically the application, but they forgot that you can't just jump headfirst into application development. That is true for if you're doing like a hobbyist projects, whatnot. If you're learning, I would say, if you're learning a programming language or a platform or a framework, whatnot, that's good. But if you want to create a project, you definitely should plan ahead your work. Then we'll be talking about application development workflow, which might be surprising how complex it might get, and then how it does simplify basically your code maintainability and quality. I will touch base on full stack approach, because when you write applications nowadays, you cannot isolate the mobile applications by itself and then make it run, I would say, standalone. Most of the applications nowadays, they have at some point to get access to some APIs to pull data and whatnot. And then lastly, I will touch base very shortly on how the best practices, or how can you basically publish your applications to both the Apple Store and as well as the Google Play. So the first topic then is the evolution of application development. As we used to, the big players in the market nowadays are Android, obviously, and iOS when it comes to mobile applications. So these two technologies were in the game since the beginning of application development. And Android basically is based on Java as a programming language. And Java has basically mutated, I would say, and now Android is using more Kotlin, which is like, I would say, quote, JavaScript-like programming language, more like TypeScript programming language. It's basically Kotlin makes it easy in a sense where it does hide stuff that you don't need to see in your code base. Java in the other side was a bit too verbose, and then people were complaining basically about that in the past. So the main programming languages for the time being are both Java and Kotlin, but I would put an asterisk on Kotlin because Kotlin seems to be the future of Android implementation language. And I did add Tizen in here because this is one of the newcomers, and then it is maintained and released by Samsung, and it targets mainly the Samsung devices like phones, watches, whatnot. And Tizen, I won't call that a language. I would consider that more like a compiler or transpiler, because you write your application and you can write your application in JavaScript, HTML, CSS, and then Tizen takes care of basically compiling your application into either a mobile or a mobile or a wearable device. Then the other big player obviously is Apple with iOS. And if you want to program applications that do run on iOS, you have to use either the Objective-C language, which is one of the, I would say, the older languages, and then, or you can use Swift. Swift is similar to Kotlin. From the syntax perspective, it does kind of remember a bit. It has some similarities with JavaScript, but it's still, I would say, tailored to the iOS developments. So these are basically the first pair, and we see from here that we do have some kind of evolution in terms of the languages that we're using per se. So the languages are changing because the need for new languages are rising every year, basically. So to summarize this, when you implement your application with iOS for iOS or Android using either Swift or Kotlin, I will be considering only these two, not Objective-C and not Java. What you will technically do is what we call native application programming. That is, you're creating an application that will target one device. Either it's going to be iPhones for iOS or iPads, whatnot. I would say iOS devices, or Android devices. So by doing that, you will have to write a code that runs on Android, on iOS, and one that runs on Android. So as you can see, you already have like a split of your code bases. So we'll have one code base for iOS devices and the other code base for Android devices. So, and that's where you ask a question to yourself is, if I want to get one product that runs on two devices, that means I have to have two teams. And if you have two teams, then you have to make sure they work in sync. And sometimes this might be a source of problems, in a sense where the synchronization between the two teams might get lost with time. And that you can see that in some applications, like for iOS. I can give you the example of Procreate, which is one of the famous drawing applications for iOS. And these guys decided, you know what, we're going to stick only with iOS, and we're not going to bother creating anything for Android. And similarly, there is some applications in Android in the App Store that did not get translated to iOS. So the main point here is, by having two code bases, you're adding a little bit of complexity to your app if you wanted to target both technologies. So then people start thinking, how can we build for two targets by using only one single code base? And that's where JavaScript people came up, and then they were like, why don't we use just JavaScript, CSS, and then write our code in a single code base here, and then create a way to compile it into a sort of a web view, which is basically just a browser without the frames. So from the user's perspective, the users that are looking at the app, like if it was native app, but practically speaking, it's just a web browser that shows JavaScript and HTML and renders them on that web view. And by doing so, then you solve the problem of having two code bases, because now you can have only one team that works on one single code base, that maintains that code base, and then that builds it to target two devices. This has basically solved one problem, but there are many other problems that did show up. For instance, like performance. When it comes to performance, this might be a bit tricky, especially if your app is using hardware on the devices like cameras, Bluetooth, geolocation, whatnot. So that might be a bit tricky. So, but the community around what we call hybrid application development got more power, and then more people were like loving this approach since it was simplifying their life easily. So now one person can basically release to two devices. Then Google got into the game, and Google was like, all right, we solved the problem of single code base. However, we're still having problems with the performance. How can we solve that? So what they did is they came up with Flutter. Flutter is a framework that uses its own language, which is called Dart language. Basically, Dart looks like Swift, which looks like Kotlin. So Dart is inspired by Kotlin, since Dart is created by Google and Kotlin was created by Google. So the language per se, to learn it is not that difficult, but what it does is pretty impressive. So you write your code base with Dart language, and then you compile it to bytecode, which means native, to either iOS or Android. That means you're not going through the web view. Now what you're really getting either IPA for iOS or AAB for Android. We'll talk about those ones in the upcoming slides. And now we solve the problem of both single base source code and performance. So a bit more on that. So if we have to compare and leverage all these technologies, when you look at the native, they were suffering from multiple code bases. However, they had like a performance. When we talk about hybrid, it's the other way around. So hybrids, they have low performance, but they have very low performance, but they were based on a single code base. So in terms of maintainability, it was pretty kind of cool, because now things are got significantly easier to maintain. And the last point here I put is orange, because I don't want to put red nor green, because uniform UIs, since you have one single code base, that will give you uniform UIs. So, but some iOS users, for instance, they prefer to, well, they use iOS because they like how it looks, on how it performs, whatnot. So they prefer to have the UI that looks like an iOS app. So that might be negative, and other users basically don't care. But the either UI that you presented them, they just take it. So that might be a bit kind of confusing, because if you have a UI, people don't like your UI, then there is a big chance that they're not gonna use it. So when we talk about hybrid, the schematic here is oversimplified, because what's hidden behind it is a lot of framework, a lot of technologies that basically the main objective of these technologies is to take the JavaScript code and then mingle it around and then try to spit out something like that works on both on the web view. So one of the most famous one is Ionic, I would say, which is based on Node.js. So you basically write, just like you write your website front end, and then Ionic takes care of compiling that into a mobile-friendly version. The other one that's kind of famous is PhoneGap, that's released and maintained by Adobe. It does more or less the same thing. I didn't cite all of them here. This is just like a small, I would say, snapshot of what's out there. We can think about React Native, for instance, React Native, which is based on the React framework, which is one of the famous framework, Facebook's framework. So then, if we have to leverage what's so-called the Flutter, we can see that in terms of performance, it gives you pretty decent performance because you're building, you're compiling to bytecode, which means it's like you're using the native code. And it gives you also a single code base aspect. So you don't need to split your app into different projects and have to maintain the two streams of your projects. It gives you possibility to implement native UIs. So you can either detect, am I on iOS or am I on Android? And then based on that, you can present to the users the proper UIs. So you make everybody basically happy. And the last point is really important because this is maintained by Google and released and maintained by Google. And as you know, Google is releasing and maintaining also the Android kind of platform. The Kotlin platform. So the very I would say the company who created the Android basically operating system is creating something that you can use for iOS compilation process, which is kind of at the beginning it was kind of surprising, and then with time this is getting more and more acceptance by the developers, and then a lot of people now are getting into Flutter. The thing with the if I go back 2 slides, the thing with hybrid applications is basically what you're doing is you're creating sorts of websites that do run without the browser. But yet, once you compile your code, you have to submit it to the stores, either the Apple Store or the Google Play. For Google Play, that's pretty much kind of easy, it goes through. But for the Apple Store, it might get a bit tricky because the reviewing process is a bit hard. So this adds like more stress and kind of more overhead. So if your solely objective is to create application that does not use any hardware capabilities, so why don't you just use what you call responsive UIs, responsive websites? So for responsive websites, what you do is you have obviously single code base because you're creating websites. Your website can run either on the phone, on a tablet, or on a computer. And then, of course, obviously, the main requirement here is you should not be using any of the hardware on the device. And obviously, it gives you uniform UI. So the choice, at the end, the choice is yours. So you pick whatever option you want to go for by leveraging what do you need, and in addition to some other requirements that I will be presenting in a bit. So now we come to how you can effectively plan your application development projects. So whenever I start projects, I resolve this kind of 3 equations. The first one is if you want to be productive and efficiently productive, you have to consider both the resources and the time. And the resources are tightly coupled with the budget, among other aspects that I will inject in there in the upcoming slides. And the time is also tightly coupled with the context. And I will explain what do I mean by context in a couple slides. So in terms of resources, I did add this slide here because this was in one of my earlier presentations, which might help. If you're not a developer, for instance, and you basically wanted to create an application, you have to leverage how the resources you have access to. So if you want to build an in-house, like you have in-house resources like manpower, you have developers, you have designers, then yeah, you can go ahead and then go for in-house production. But also you have to consider the infrastructure. So data centers, servers, and whatnot. If your application is using some sort of a backend to pull data or to save data into, then you might want to consider having some sort of infrastructure in-house. The other option that you have is outsourcing. So you might just get freelancers to work on your projects, or just hire a private company that does application development, and they will take care of the whole process basically for you. But that if you go that way, then the budget variable is going to go a bit higher. Remember in that previous equation. And then for the services, you don't need to have your own infrastructure. You can basically use the platform as a services like Google, Amazon, Microsoft, and whatnot. And then they will take care of basically hosting your back-end application, your back-end side of your application. So all you need to do is just basically maintain the code of your server. I will be giving a bit more details on how this works in a little bit. However, whichever option you want to go for, there are some criteria that you want to keep in mind, and this is true for either you are a developer or you are a project owner. So the first aspect is called separation of concern. You should not pollute your views with extensive logics. So what do I mean? So assuming if you are a developer and you're working on pure logic, like you're implementing the logic behind your applications, then you should not include anything that has to do with what we call the view or the presentation. What people see is not, they don't care of what's going on behind the scene. What they see is what they see basically, and what the logic behind this should be taken care of different components. So my question, why should I do that? And why is it even important? Well, it's to create a harmony between front-enders, what we call front-enders, designers, and front-end developers, and the core developers. The core developers are the ones that are working on the logic, and the front-enders are the ones that are creating what the user is going to be looking at. So by splitting these two elements, then you can basically tell your designers to work on the front end, and tell your developers, the core developers, to work on the logic behind it. So when the user clicks on the button, then what's going to happen? That's a core developer who's going to do that, and so on and so forth. And also this is true, I'm not citing that for all of them, except for the last point. It is good for testability of your code. If you want to test your code before releasing it to production, this is definitely something you have to do. The second point is modularization. So that means you have to split your code in multiple small chunks or modules. Why would you want to do that? Well, if you are a developer, and your app is big, you might want to share the work with other people in the community or co-workers. So by splitting the code into small modules, then it is going to become easier to split the tasks between all your collaborators. If you are a business owner or project owner, then what you want to do is, by splitting that, you can give small chunks of codes to different freelancers, for instance, or different developers if you have in-house developers. That helps you out basically not being dependent on one single source for basically doing your for implementing your entire application. And the last point is what you call a single source of truth. What that means is basically the state of your app, the data from where the app is getting the data, basically the place where data is getting the app from, should be completely independent. And that is important for both testability of your app and also for leveraging databases. Assuming for some reason you choose one type of databases, like the ones that we'll talk about later, like non-SQL database like MongoDB, and later on down the road you decide, you know what, now I have to I have a big chunk of data that I want to process, like with indexing, whatnot. So I need to do a lot of data processing. If you want to do a lot of data processing with where indexing is really important, sorry, then you might want to go with SQL database. So then you have to drop the Mongo DB, which is not in SQL database, and then you have to switch to something that's SQL database. Then by separating that source of data, then what's going to happen is it's easy for you to just unplug the Mongo and plug in the SQL database, and you're pretty much done. If you don't do that, then you have to rewrite the whole thing or troubleshoot the whole app, and trust me, it's not pleasant to do. So these are 3 points that, in my point of view, are really crucial and important to write clean code and then have maintainable, basically, application development process. So I will be touch basing a bit on the workflow, basically, how from the idea or from the ideal requirements, how would you work your way down to create your application? But first, I'd like to mention these 2 sentences. So the first one is, users, they don't care if you're smart or not, as long as you solve their problem. So, and second one is, don't push technology to users, rather use it to solve their problems. So whenever you start a project, if your goal is to take technology and just push it out there just because it's a buzzword, like, I don't know, AI, you heard AI, okay, I have to build an app with AI. Well, does it solve any problem or not? But just keep those 2 points in mind. But I keep repeating myself when I say these 2 points, but they're really important and crucial for the success of projects. So as per the workflow, every project will start with an idea. Once you have the idea per se is like organic elements in your head. It changes like over time at very high pace. So you have to capture a certain time your idea, and by doing that, you just have to. If you want to do that, you have to sketch it. Once you sketch it, you validate your sketches. If you have a team or co-workers, whatnot, and once that's done, you move on to what you call digital prototyping. So a digital prototype is basically the sketch that you drew with your pen and paper, and translate it into a digital support, like your computer, for instance. Adobe XD is one of the famous, I would say, product digitizing prototyping tool. It's pretty easy to pick up, and it helps you in a sense where you can also create logic between each screen. That's what we call basically user's experience, like animations and whatnot. So this point is bullet. That means, from my point of view, I consider this as a requirement. You have to do it. You can't skip it. If you skip it, you're gonna run in trouble later on. Then you do the next step will be mocking up your implementation, and here I'm talking about only the front end. What users are gonna see. That is your front end. So you create basically fake back end, some data that you store within the front end, and then you basically, by doing that, what you're gonna do is you're gonna finalize the look of your application, and you can test that across multiple devices. And once you're happy with how the application looks, and this is really kind of one of the most crucial parts, because once you're done with that, what's gonna follow is what people are not seeing. So they don't care what's after. What they care about is how the app looks, and then if I click on a button, is there any animations, what I'm going to see and whatnot. So mocking up the implementation is kind of really one of the, I would say, the important point. That's why I bolded it up here, real front end, because when you mock up your implementation, you're creating real front end, but what's mocked up is only the back end. And then once you're happy with this, you can move on to your back end implementation. And as what people don't guess that at first, but when you create an application for a mobile device, you're not doing only, I would say, the mobile application implementation per se only. You have to take care of also the back end, and that is what we call full stack developers. Full stack developers, they create the application for the mobile, but also they create the back end where the application is getting data from and where it is going to be storing data to. that is the backend integration. And then you do, I did bullet app as well because I consider it to be crucial because that what makes your app basically works perfectly. Then you don't, the next step would be logically testing your application. Unit testing, as I would say, the minimum requirement that you have to do. And why testing is important? Well, if you're a hobbyist and doing this projects for learning stuff, whatnot, you might skip testing because that's what the new developers they do. They just think, well, that's a waste of time. I know what am I expecting from this function. Why should I test it? Well, the truth is, if you have big projects and you have, remember I said one of the points that are important in app development is the splitting your code into different modules, right? So let's assume you have small modules and then you have, like I would say, 10 developers. Each one is creating one module. You're not going to go through the code of each module to just review the entire thing. It's not going to be possible, especially for big projects. What you want to do is just take that module and then test it separately from all others and then say, okay, this module is expecting a name of a user and is going to give me back how many friends he has on the back end, for instance. So all you want to do is enter the name of 10 users, 20 users, and tell that module, okay, go use those names and give me back the friend counts. And by doing that, so you're testing that single module separately from any other ones. And then if it passes the test, you say, okay, good. You give it to your chief developers and you say, okay, integrate that one into our application, and you're done. So that is where the unit testing is really kind of important for big projects. And then the logical next step would be to build and release your application for beta testing. So beta testing is you release your application on the stores, but only limited number of people can access to it. So for Android, that's called a test track, and then for Apple Store, they call that test flight. So you have to download the application test flights, and then you'll be part of the testers. And then obviously, whenever you release for beta testing, you will have some feedback, and then you just integrate that feedback into your main application, and then you look over. Basically, you improve, you rebuild, you improve, you rebuild, and so on. And once you reach version 1.0, then you can consider yourself as ready for release, and you can release for production your application. And once you do that, that's actually where the I would say the tough work starts, because that is where you have to maintain your application's performance based on users' feedback. If you make them happy, then you're happy. Then you can be successful. If they're not happy, then yeah, you're gonna run into some trouble. So remember here I talked about front end, which is what users will be seeing, and then the back end. So if you combine those together, that will give you what we call a full stack. A full stack is basically a developer who can basically do both front end and back end. Because remember at the beginning, iOS and Android, we had two code bases. So now we're facing more or less the same problem, because now you have to have a developer who is focusing on only front end, and another developer who is focusing only on the back end. So then here we go. You're creating again that problem of synchronization. So there are some developers who are really good at doing both of them, but I will rather recommend for bigger projects getting one specific developer for front end and the other one for back end, since the technologies between the two are not really that similar in terms of implementation. So let's try to then see how can we basically improve our workflow based on some criterias. So the first question you want to ask yourself before starting implementing, once you have the sketch, prototype, and whatnot, then now you're ready to kind of, okay, you know what I'm going to do now. Let's think about the architecture. How am I going to architect my application? So what you want to do is you want to be as productive as you want, as possible as you can. So you want to increase the resources and reduce time. That's the ideal situation. So for resources, as I said, they are linked to the budget, and the time is linked to the context. So the time, when I say context, it could be a product context. Assuming you have a product that's already running, and then you just want to add some functionalities into it. So that gives you, I would say, less time, because whatever you're going to implement is not it's not full project. You just a piece of a project. And the other context is pandemic, for instance. And this is perfect time we're talking about this, because before people would like work pandemic. I mean, they won't see it. But for COVID-19 situation, for instance, the context will shorten your time, which means now there is emergency. I need this app so people can use it during this period of time, and then they can benefit of it. So you can't spend that much time developing your app. You want to shorten up as much as you want your development time. And when it comes to the resources, well, they depend on the budgets, obviously, on the experience. If you have experienced developers, and collaborators. If you have only one or two or three developers, do you have designers and whatnot? So more collaborators you have, less more the resources. Basically, the resources, more collaborators you have, and bigger are going to be the resources basically you have in terms of manpower. And the resources that I include here that I will talk about in the two upcoming slides are basically the back end resources, like the server, the database, and whatnot. And obviously the budgets. If you have big budget, then you can increase the resources variable, and then you improve your productivity. So when it comes to coming back to Flutter again here, so because some of the questions I get all the time is, well, if I use Flutter, that means, well, I'm not really writing any native code in there, and then the people I work with already, they are good at either iOS or Android. So why should I change? Obviously, the answer is yours. You do the way you feel it correct to do. But if your business or your skills are only in iOS, for instance, right? But you want to expand and you will scale up and to cover also Android devices. So you might want to think about kind of relearning a bit of Android and whatnot, right? Or hiring people that do Android. But if you use Flutter, what you can do is you can still write your code with Swift, same as before, no changes. And what you're going to do is create what you call a channel. And the application channel, what it's going to do is you can save your iOS code within the Android projects and tell Flutter, within the Flutter projects, and tell Flutter to include that in your compilation process. And that's it. You don't need to write, I mean, you have to write some Flutter with Dart code, but the bottom line is you can use native code in there and then inject those native codes within your application. And then in a matter of seconds, you get basically the version for Android and for iOS without that much of a hassle. This might help your productivity in a sense where it can shorten that basically the resources that you need. Is going to improve the resources variable basically, if you can put it that way. So now let's tackle a bit the full stack approach, because we need some backend for our application in order to kind of properly kind of function, right? So when I talk about backend, basically it's everything that has to do with the cloud, right? Server. So you can have either what you call serverless backends. You can have a server backend that you build on your own, and you ship it to somewhere like Heroku, whatnot, AWS, and then you have a database. These three components will basically form the backend of your application. So let me give you an example of a typical architecture that you can build. So this is my personal preferences. So if you don't want to use Flutter, you can use iOS or Android, up to you, right? But still, I mean, iOS and Android can be injected in the Flutter, so why not? So the first approach is to use a backend. If you're experienced developer or you have some good backend developers, then what you want to do is just write your own backend. And the technologies you might want to use for servers, well, there's Node.js, obviously. You can use PHP. You can use other technologies like C#, Python. You name them. Here, I just picked some examples based on my preferences, right? Apollo server is good in a sense where you can integrate as well GraphQL into it, but that just consider this as being just backend and the way you're getting the data basically, right? So in one side you're doing what you call REST API, and the other one you do like a GraphQL API. And the other option you want to consider is a database. So you want to go either with a MongoDB, which is a non-SQL database, so as collection of documents that you store on the cloud, and you basically request one document at a time. Or you want to go with MySQL. MySQL is for when indexing is important in your data. So when you're doing a lot of kind of algorithmic mingling with your data, so then data-driven basically applications should use definitely MySQL. The other option you have is using serverless. So by using serverless, what you're going to do here is you're going to reduce the time variable because you don't need to implement the whole thing on your own. And serverless, you can use either one of the server providers, like a platform as a server, as a service. So an example would be like here, Firebase, for instance, Google products, or AWS Lambda, which is AWS products, Amazon products. So what they do basically is they take care of the whole thing for you. They take care of the server side, they take care of the database side. You don't need to worry about all of that. But here you're reducing time, but in terms of budget, you're increasing the budget variable because this comes with some costs, obviously. And the last option, which I put in here, it's not completely, the arrow is bit before the platform as service, is by using what we call headless CMS. Headless CMS is basically, it simplifies for you the implementation of a server and database. You basically provide it with a server, with a database, and then that you purchase out there. Like I have a Mongo account in there, and then I have like Heroku account in there. And then it shows you like a UI, and then you can do everything through the portal. Like you have admin portal, you add users in there, you add data formats in there, whatever you want to do, you can do it with headless CMS. And it can be very quick to implement application with headless CMS. And some examples that I found very useful, we have Strapi. Strapi is a newcomer. I mean, it was here, it was released before, but version 3.0 is the most stable one. And then this is getting more and more attraction by the community. It's open source, it's free, and then it helps you basically kind of speed up your implementation process of your backend. And the other one is Webiny, which is kind of if you're more into like GraphQL and then instead of REST API, Webiny could definitely be a good choice for you. And this is for the backend architecture. But if you want to write kind of clean architecture, as we call it, considering both the back end and the front end, you want to follow Uncle Bob's recommendations. Robert C. Martin is very known in the community for as an advocate for clean architecture implementation. And then he wrote a very interesting article on how to properly basically implement your application to follow the best practices in terms of clean architecture. So the inner layer, this graph basically is the first reference to be like as the onion graph. You see the different layers of your application architecture. So the most inner layer is what you call entities. This is basically it's the format of your data, how your data should look like. For instance, if you're expecting a user count, if your application does create users, so a user might have like a username, password, email, whatnot. So this is your entity, basically the data, the shape of your data. And then the layer just next to it is what we call use cases. Use cases, what do you want to do with your entities? For instance, in our example, you might want to get a user or save a user or delete a user, whatnot. So this is different layer, you see? So you're splitting up basically your code into manageable small layers. And then you have controllers or presentation layers, gateways layers. So for this layer, it's basically everything that has to do with the state of your application. Like for instance, like managing the state. Whenever I get something from the use case, for instance, I want to pass it over to the view. Like I get a new user did update the username. Now I have to pass the new username to the viewer, and the viewer reacts. And this is basically the logic behind what you call reactive applications. They do react on state changes. And well, for in terms of architecture, whatever you choose at the beginning, you have to keep it up until the, I would say, until the version 1.0 to respect what we call the consistency of your code. And you could either do it, as I said, you could either do it on your own, or you can basically do it through I would say outsourcing, right? So by implementing such architecture, you have to leverage some pros and cons, I have to say. We don't have a perfect way of doing things, right? So when you do it on your own, let's say you have your own developers, or you are a developer and you want to do, you want to implement your application on your own. So the pros of this is that you have full control over the architecture. You can choose Uncle Bob's, for instance, clean architecture, and you can keep it up until the end of your projects and beyond if you want. And you can also adapt your implementation pattern the way you want it, right? You want to do it like through Flutter, okay. You want to do it through iOS, to Android. It's at the end, it's your own choice. You're completely flexible. And it is kind of free because, well, you're doing it on your own. So, but obviously, if you are a company owner, it's not completely free. But what I mean is there's no extra charges for that. The cons on the other side is you have to be good at security, because if you miss a one security hole in your application, then you basically are kind of in trouble. Efficiency, you have to force yourself to be consistent in your architecture implementation, and then you cannot start your project by deciding I'm going to do it with Flutter, and then right in the middle of the project you do like, you know what, I like the old days when I used to write with Swift, so let me move back to Swift only. Then that is not acceptable. I mean, you can do it, but it's just going to be, in terms of productivity, is going to kill your products. And the last point, which might depend on your level of experience and how many people are working with you, is the time. Obviously when you do it on your own, it's going to take you a bit more time than if you do it with already kind of established structures. And when we talk about I would say serverless applications, so this is, by the way, only tackling the server side, okay? For if you choose a serverless solution, basically the pros, I mean, I put one point in there, and honestly speaking, it's very fast in terms of time. I mean, you create an application in one day, and the full-fledged application, you can do it in one day. But the cons, obviously, is you will be depending on a third party all the time. I mean, you don't decide on how to lay out your data. They will tell you, okay, do this and that and that, and then submit to us, and then we'll keep up your product. So you have to keep kind of the philosophy of implementation has to be basically coming from them. And if they do some breaking changes, assuming you choose like a free, I don't know, like CMS, or I don't know, like a Strapi, the example we gave earlier, and then the developers, since it's maintained by the community said, okay, we don't like the way this is implemented, the authentication process is implemented, so they did some changes, and that broke the whole previous version. So now it's version 4, it's not anymore version 3. So, well, you have to keep up with that. So you have to kind of get in sync and re-implement the missing, basically, the functionalities. And of course, they do impose some implementation pattern as well. They have language they used for implementing that particular library or framework, so you got to keep up with that. And obviously, the costs. Some of them are free, some of them are costly. So for the free ones, they are the ones that they might suffer from these 2 points, like the breaking changes and then implementation pattern. Well, if you go with the paid ones, since you're paying, they offer you a bit more flexibility. So they won't release any breaking changes, whatnot. So And by talking about breaking changes, the latest one that came up is from the creator of Node JS, which is Ryan Dahl. When he was young, he created an application that now is becoming the de facto standard for implementing a backend basically applications. And like last month, he came up, he said, okay, well, what I have done before, I was young, I didn't think about some points, so now I'm kind of correcting my errors and I'm releasing some new, like uh, a new framework that people have to use. So now you see the stress of moving from one framework to the other one. It's creating a lot of kind of noise among the community. So let's kind of summarize up this a bit and just see, well, leverage what can we use and then how can we choose basically which options should we go for. So the first approach, as I call it, Scratch, but Scratch and templating, that's what I call home build, right? You decide to make your application. So the experience that is required from someone who starts from scratch, obviously, it should be high. You should know what you're doing before you do it, actually, right? Especially when it comes to security concerns. The cost obviously is going to be low because you don't have any extra costs. You're doing everything on your own. And the time might be significant, depending obviously on your experience. But most of the time, you have to take your time to implement something correct. From templates, that means you are experienced developer, so to some extent developer, and you have access to some templates, like a server template. It is already in there present, so you can use it. So the cost is still low, but here I make it a little bit bigger, the high word here, because you have to make sure what you're using. Those templates, they might be safe, they might not be. So you have to first understand the templates you're using before basically using them. When you use CMS, the experience, you don't need to have that much experience because it's, you got a portal. You plug in your data in there and then you're done. So the cost may be medium, depending on what strategy you want to go for. You can go with open source, like the Strapi one, but if you go that way, you got to be ready for breaking changes. So they won't ensure you like continuity, and the time might be medium, yeah, too low because it's pretty quick, yeah. And backend as services experience there, I mean, you have to have some experience in how to manage platforms, but not in terms of implementation. And the cost of these ones, they might be a bit higher. And usually they don't give you like fixed costs. I mean, they give you like over time, how many times you have access to your backend, or things like that. Yes, how many emails you send and stuff like that. And then the time obviously is going to be very low because one of their selling arguments is that you create your application in no time. So this summarizes basically more or less our talk about the back end implementation. So before I leave you, I just want to touch base one slide, I believe, on the how would to submit your application to the stores. So once you have your application kind of done and then you compile it. So if you want to submit to the Android store, you want to have an account with them. It's $25. This is one time you just pay it and done. For iOS, you have to pay $99 per year. For Android applications, you must have the .aab, which is the new standard. APK, you can still use it, but in the near future, they will basically use only .aab, which is Android Application Bundle. And for iOS, obviously, just IPA, single kind of extension. You must have some sort of privacy policy, especially if you're using your login users and whatnot. So you're using emails, if you're saving their names, their data, like images, whatnot. You should definitely have privacy policy. With Google, maybe you can go through without, but for iOS, they will definitely review your privacy policy if you're collecting any information from the user. And for Android, you must, I would say, you have to, although it's not requirements, but you have to go through the test track. Just test your application with some limited people. You get a link, you just send it to them, and then they will download the application, and they will test it for you just in real time, in a real environment, right? And for iOS, it's called Test Flight. For Google, you can add up to, I think, I don't remember exactly the number, but for the test flight, 10,000 users can basically access your your application. For Google, I don't remember exactly the number of the users you have. And then you submit for review. So this takes now 1 to 2 weeks because we of the current circumstances, they don't have much I would say reviewers as like manpower. But for iOS, it's surprisingly quicker nowadays because it takes 12 to hours and it might be 1 week. But so far, all the apps have submitted during this period of time. It was like less than 12 hours. They were reviewed basically. That's gonna be it. And the last slide I would say is the success of your application is not defined by the time you release it. No, that's complete fake news, right? Once you release your application, that's where basically the work starts. That's where you're gonna be maintaining it. You can see if people are liking it or not. That's where you will have a lot of bugs coming back to you, and you have to debug them because now the app is live. So which means you can't wait. You can take your time. So that is where the hard work, I would call it, quote unquote, starts basically once the application is installed. So thank you very much. Sorry for going quick at the last because I saw that you are running out of time. I hope this was kind of informative for you. And if you have any questions, please don't hesitate. Just toss them on the Q&A. I will be happy to answer them. Thank you very much. Things are evolving very quickly. I mean, you should not keep your. I mean, you should basically use whatever you know as technology to implement your applications, but never forget to keep like your learning. I would say options open because by the evolution of mobile phones and computers, you will definitely see new ways of implementing applications that will kind of get released, and you have got to keep like your don't stick with the old-fashioned ways. That keep your kind of motivation to learn new technology open. And that happened to me as you could, actually for Flutter. I didn't believe in that at first, but then when I gave it a shot, I was like, wow, this is amazing. I mean, this is definitely something that's gonna become more and more popular among the development community. Well, so I think we're gonna finish here. But please, if you have any questions, whatnot, I think my email is in the listing. Don't hesitate, just toss me an email, and then I will be definitely happy to answer your emails later on with pleasure. Thank you very much, guys.